This project is a virtual reality medical training system designed to create an interactive and immersive anatomy learning experience using VR technologies. The application is built in Unity using C#, OpenXR, and the XR Interaction Toolkit, with a modular architecture focused on scalability, interaction handling, and performance optimization. The system begins with a centralized VR dashboard where users can navigate between anatomy labs, monitor progress, and access different learning modules. Each lab follows a structured three-tier workflow consisting of Learning Mode, Explore Mode, and Interactive Mode. Learning Mode is a guided experience where users progress through anatomy lessons step by step. Each stage dynamically loads anatomical models, instructional UI, diagrams, narration, and interaction tasks through a scene controller system. The progression logic is handled through modular lab controllers that manage arrays of lesson states, model references, transforms, interaction conditions, audio playback, and progression validation. Users interact with anatomical structures using VR controller-based interactions implemented through OpenXR and XR interaction systems. Object interaction events are connected to custom validation scripts, which determine whether the correct anatomical structure has been selected before allowing progression to the next stage. For more complex anatomy regions, hierarchical interaction systems were implemented so grouped anatomical structures can share interaction logic while still supporting individual object detection and manipulation. The system also includes persistent progress tracking using centralized singleton-based managers responsible for handling user state, lab completion data, and session progression. After completing guided lessons, users unlock Explore Mode, where anatomical models can be freely rotated, scaled, and inspected in real time for detailed observation. Interactive Mode extends this further by enabling full physics-based interaction with skeletal structures, allowing users to manipulate individual bones directly inside the VR environment. A major technical challenge during development was optimizing collision systems and rigid body interactions across highly detailed anatomical models while maintaining stable VR performance. To address this, the application separates interaction complexity across different learning tiers, reducing unnecessary physics calculations during guided learning while preserving full interactivity in dedicated exploration modes. The UI system was also separated into dedicated managers to improve responsiveness and reduce interaction conflicts between world-space VR interfaces and physics-driven objects. Additional systems implemented include anatomical terminology modules, anatomical plane visualization, assessment functionality, quiz tracking, and user analytics integration. The overall goal of the project was to combine immersive interaction, modular VR architecture, and structured educational design into a scalable medical training platform capable of improving engagement and spatial understanding in anatomy education.